Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, today we are going to learn about reactions of phenols. Phenol as a class of organic compound in which hydroxy group is attached to the aromatic ring. So they will show the reactions both like the alcoholic group and the aromatic structures. It is mentioned over here that phenols undergo two types of reaction involving breakage of O to H bond, results in the formation of ether, esters, and salts. And phenols undergo electrophilic substitution reaction on the aromatic ring, such as nitration, sulphonation, acylation, alkylation, carboxylation, and halogenations, and many other reactions take place. So one by one, we are going to consider the different types of reactions that phenol undergoes. First one is reaction involving the breakage of OH bond, and in that case we are going to consider the salt formation. Salt formation is actually related with the acidity of phenol. We say that phenol having pK value 10 are much stronger acids as compared to alcohols, and they can easily form salts with the weak bases. Like aqueous sodium hydroxide over here is reacting with phenol and forming the sodium alkoxide ion. But these are quite stable in the solution of sodium bicarbonate, and this is the identification test of the phenol, that they are soluble in aqueous solution of sodium hydroxide, but they are insoluble in aqueous solution of sodium bicarbonate. And they can easily be identified from the alcohol, because alcohol having a carbon number 5 or greater than 5 in their chain cannot dissolve in aqueous solution of sodium hydroxide. Next one is Williamson ether synthesis. In this case, phenol is made to react with a base, and phenoxide ion is formed, and in the next step this phenoxide ion, acting as a nucleophile, will react with alkyl halide or methyl sulfate and replace the halide ion or the sulfate ions, results in the formation of alkyl aryl ether. Different examples are shown, in which nitrophenol is made to react with methyl sulfate in the presence of aqueous NaOH and heat, and results in the formation of orthonitroanisole. Paracresol is made to react with para-nitrobenzyl bromide and results in the formation of para-toluyl para-nitrobenzyl ether. Next one is ester formation. Phenol in the presence of an acid or a base are converted into esters by the reaction with acids, acid chlorides or anhydrides. So here it is shown that phenol on a reaction with acid chloride is being converted into esters, and similarly phenol on a reaction with sulphonyl chloride is also forming the sulfonate esters. Phenol on a reaction with benzyl chloride in the presence of NaOH will form phenyl benzoate. Here the H and Cl will leave, and rest of molecule will combine with each other and form phenyl benzoate. Para-nitrophenol is reacting with acetic anhydride and forming para-nitrophenyl acetate. And in the next case, orthobromophenol is reacting with para-toluene sulphonyl chloride, and we are obtaining orthobromophenyl para-toluene sulfonates. Aspirin. We say that this reaction is quite important in the preparation of aspirin. Aspirin is a medicinal compound that is used to reduce the fever and to reduce the pain. So it is used in all those medicines which are mostly used to reduce the pain and to reduce the fever. And here the salicylic acid is made to react with acetic anhydride and acetyl salicylic acid, that is called as a aspirin formed, and acetic acid is also formed in this reaction. The other type of reaction that occurs in phenolic compound are electrophilic substitution reaction on aromatic ring. Phenolic group increase the reactivity of benzene ring towards the electrophilic substitution, as we know that this hydroxy group is orthopara directing, and It increases the electron density at ortho and para position, and next electrophile can easily attach at ortho and para position, and the non-bonded electron pair that are present on the oxygen of hydroxyl group actually stabilize the oxonium ion that is formed as a intermediate in those electrophilic substitution reaction. So we say that if phenol on a reaction with a suitable base like sodium phenoxide ion and get converted into phenoxide ion, the reaction with phenoxide ion is more speedy reaction, and the intermediate forms are also more stable as compared to phenol itself. Nitration, phenol on treatment with concentrated. Okay, nitration, phenol on treatment with concentrated nitric acid is converted into picric acid, and in order to avoid polynitration, nitric acid at low temperature is used, and in this case we obtain a mixture of orthonitrophenol and paranitrophenol, and both these isomers can be easily separated from each other by the distillation. Sulphonation, we see that here phenol is reacting with sulfuric acid and forming the orthophenol sulfonic acid and paraphenol sulfonic acid, and we say that this reaction is temperature dependent. At low temperature the orthosulfonic acid is being formed as a major product, and at a higher temperature the parasulfonic acid is formed as a major product, and at the 100 degree centigrade temperature the orthophenol sulfonic acid will itself get converted into parasulfonic acid. Halogenation, treatment of phenol with aqueous solution of bromine results in replacement of every hydrogen ortho or para to the hydroxyl group, and even cause displacement of certain other groups. So phenol on reaction with aqueous bromine solution is forming 2,4,6 tribromophenol. All the ortho and para hydrogen to the hydroxy group of the phenol get replaced with bromine. So here at para sulfonic acid group is present, and this sulfonic acid group will be readily replaced by the bromine when it is made to react with aqueous solution of bromine. And if we are interested in monohalogenated product in the presence of weakly polar solvent, bromine at low temperature will be made to react with phenol, and this would result in the formation of para-bromophenol. Here, because of the greater reactivity of phenol, we do not require any Lewis acid in order to facilitate this reaction. Alkylation. Because they are highly reactive, phenols are usually alkylated or acylated using relatively weak Friedel-Crafts catalyst. To avoid over-alkylation or over-acylation, phenol is quite reactive, and its ortho and para hydrogen get readily replaced with alkyl group. So in order to prevent that, we will use a weak Lewis acid, and in that case we will react the alkylating agent with the phenol, and here the alkylation take place. So alkylation, Friedel-Crafts alkylation take place in case of phenol, but this reaction is not appreciable because good shield is not obtained in this case. Acylation, in the presence of Lewis acids, acylation of phenol take place, but direct acylation of phenol does not take place. Phenol on a reaction with the octanyl chloride is first forming the oxygen acylated product, and this oxygen acylated product then in the presence of aluminium chloride and aqueous HCl will rearrange to form ortho-hydroxyaryl ketone and para-hydroxyaryl ketone. Mixture of these isomer will be formed, and these isomers are also actually easily obtained from each other, because this ortho hydroxyaryl ketone will readily form intramolecular hydrogen bonding, and they undergo the chelating process, chelation, and they have low boiling point and easily obtained from the reaction mixture. And here the yield is also temperature dependent. We say that metacresol is when made to react with acetic anhydride, and we say that metacresyl acetate is obtained on the reaction with aluminium chloride at 25 degrees centigrade. Para substituted product is the major product, and at 160 degrees centigrade ortho substituted product is the major product, and this reaction is called as a Fry's rearrangement. Thank you so much. More reactions of phenol will be discussed in next video.